Welcome to the lecture on Introduction to Risk Measurement. So, in this lecture we are going to have some concepts about certain terminologies related to risk measurement, especially the risk related to return, and in that we will be having the introduction to certain terms like what are those parameters by which we measure those risks, and what is the significance of those terms and all that. So, first of all let us see how this risk measurement is important in the financial aspect. So, assessment of risk and return, they are two of the most significant determinants while taking major financial decisions. So, when we talk about financial securities like shares or bonds, or in other investment assets like like stocks and bonds and other investment assets. Now, in those cases everybody wants you must have the assessment of the risk and return, because many a times you are you are investing something for getting some return. Now, in many cases you may get large return, and in many cases you do not get such a large value of return, but then there is risk associated. Whenever in most of the cases when you are getting the opportunity to have very large value of return, at the same time there will be risk involved, and if you have low risk involved, then there is low return. So, all these things are there. Risk refers to the chance that an undesirable event will occur, that is in a financial sense chance to incur a financial loss. So, it will be a chance, it refers to that chance that something undesirable may happen, and because of that there is quite a possibility that you can incur the financial loss. So, when an investment opportunity is dubbed as risky, what does it mean? It would be thought to have a stronger chance of bringing a financial loss and vice versa. So, whenever we tell that this investment opportunity is risky, means that there is a strong chance of the financial loss into that investment. Now, investment risk refers to the probability of having low or negative returns on invested assets. So, that is what investment risk means, that you may have low return, or maybe that you do not have any return, in fact you are incurring the loss in that there is a negative return, that and the higher the probability of getting a low or negative return on asset, the risk that investment would be that much higher. So, that is what the meaning of the risk it is. Now, when we talk about the risk or when we talk about the return, what we get in that, we know that what is return, whatever you are putting some money for into an investment, and you are getting something back. So, you will be getting something for that as the loss or profit. So, based on that you are getting some return, and then there will be rate of return also, that will be in terms of percentage. So, many a times we try to quantize it, or try to express it, or we try to calculate it. When there is risk involved, it means there is chance, there is probability. You are putting an investment, so certainly there is risk involved. There is you cannot say that you will be getting this return, you can get the return even more, you can get the return even less. So, based on that you have to calculate. So, based on that there are certain terminologies, and among that measurement of risk. So, that is how risk is measured. Now, what is the what are those parameters by which you can measure? So, first is the expected rate of return. So, expected rate of return means it is the sum of products of individual returns and their probabilities. So, what happens that many a times you have certain individual returns and also the probability is associated with that. So, in those cases you have to define. So, this definition is there for the expected rate of return. In that you multiply the individual return with their respective probabilities and then we sum it. So, that will be your expected rate of return. So, for example, if so this is basically represented as expected rate of return K e. So, and K is the individual return. So, K I is suppose the individual return and your P r I is the associated probability. So, that is your P r I will be their respective probabilities. So, this is for certain investments. Suppose now in such cases there will be expected rate of return and this will be calculated as summation and I equal to 1 to n. So, and then that is your K I into P r I. So, that is your ith individual return and multiplied by the probability of that return, that particular return P r I. So, what will happen that will you will be taking as K 1 into P r 1 plus K 2 into P r 2 like that. So, it will go up to K n into P r n. So, this way you can say that you will calculate the expected rate of return. For example, suppose you have asset, you have asset X is there and this is its probabilities for certain return is tabulated. So, if suppose you have the K 1 and K 2 and K 3 that is there. So, for that the return value is 0.09, 0.10 and suppose 0.11. So, in that case what will be your and its associated probabilities are 0.45 and 0.30 and 0.25. So, suppose for getting that return of 0.09 or 0.10 or 0.11 you have the respective probabilities of 45%, 30% and 25%, altogether it is 100. So, in that case when you have to calculate the expected return on asset X. So, you will be getting a table that is will be K I multiplied by P r I. So, K I multiplied by P r I. So, if you multiply 0.09 times 0.45. So, it will be 0.0405, then it will be 0.0300 and this will be 0.0275. So, altogether if you add it will be 0.098. So, you can say that this 0.098 it is the expected value of the return. So, expected value of return is computed out to be 0.098. So, certainly we have seen that for 0.09 it was 45%, for 0.10 30 and 0.11.25. You can see from the PRI values also, if you see that it is 45% and then it is 10% is 30% is for 0.10. So, in between it will be closer to this largest value. So, it is coming as 0.098. So, this is how the expected value of the return is measured. Then the next is dispersion. So, dispersion is the difference between the highest and the lowest returns. Now, that how does that? So, basically when you have the returns of suppose 9%, 10% and 11%. So, in that case the dispersion will be basically the difference between the maximum and the minimum. So, if you try to see the asset X, now its range will be something like 2. So, this will be so 11% minus 9%. So, that is your dispersion, that is 2%. So, depending upon different values, you can find these dispersion values in such cases. So, accordingly if you have another investment and that is asset y is there, and in that case if the value is suppose say 5, 10 and 15%, in that case the dispersion will be 15 minus 5, that is 10. So, that way you will have a dispersion. So, that will be basically tell you that what is the range in which this is likely to come, and then in that if that is more, then variability is basically more. So, certainly that way the probability will differ. Now, what we see that so it means the variability is more, so risk will be more. Now, the next important term which is very important while measuring this variability, that will be basically or to measure this dispersion is the standard deviation. Now, this standard deviation is basically the appropriate tool to measure the dispersion around the expected return. So, this will be basically when you have the expected value of the return that we have calculated. Now, around that what will be the dispersion for that, this is a very important tool by which we measure the this with this standard deviation. And standard deviation basically when we talk about, so we define it like we denote it with sigma, and this sigma basically will be done by the under root of summation of k I minus k e, and then that square into p r I. So, this way you are getting the root, and I will be from 1 to n. So, depending upon the number of data, you will be calculating this is k I, this is your individual return values, and this is your expected value of return. So, you will be taking the squares of this and multiplied by the respective probabilities, and then we sum it and then we take these squares. So, that basically tells you the standard deviation. So, here you are what we see that k I minus k e, if you look at the difference when the data is varying above and below the expected mean, in that case there will be some positive values and there will be some negative values, and if you simply take the algebraic sum, then many a times they cancel each other. So, basically the total deviation, if you look at in normal sense, when you only take the algebraic sum, then in that case it may not be the true representation of how it has varied, either it has. So, variation is nothing but it is either it is positive or negative, it is all the variation from the mean value. So, for that what we do is we do the square and then we multiply with the respective probabilities, and then we sum it, and then we take its the square root. So, that gives us the value of the standard deviation, and that is a very effective tool for measuring the dispersion. So, if you see that how to measure this dispersion, now we can have certain example which by which we can see that how to calculate these dispersion. So, suppose you have asset x which is there, and in that you have the values like k I. So, k I is you have two values, we know that asset x. So, you have 3 opportunities, and the probabilities are associated as 0.09. So, that is not probability, this is the return percentage. So, 0.09, 0.10 and 0.11. And its respective probabilities we know, but we calculated the expected value of the return, and that is your 0.098. So, that is what we have calculated. Then what we calculate is we calculate the k I minus k e. So, for k I minus k e once it is taken the difference, it will be k I minus k e. So, minus of 0.08, this will be 0.02 and this will be 0.12. So, we know that we already defined its probabilities as 45, I mean 0.25, 0.50 and suppose 0.25. If suppose these are the probabilities associated in that case. So, if it is 0.25, so we can get these values like 0.25 into 0.9. So, 0.09. So, it will be 0.0225 and plus this will be 0.05 and then this will be 0.0275. So, this if you look at, so this will be 50 plus, so this will be 500 and this is 225 and 275. So, 225 plus 275. So, basically this will not be the value, because if you add them it will be 0.10. So, we can have this as the modified one 0.10, this is also 0.10 and this is 0.10. So, in that case you will have minus 0.09 minus and minus 0.10. So, it will be minus of 0.1001 and similarly you have this here as 0 and here you will have 0.01. So, that way it will be varying and then you can take these squares. So, k I minus k e, its squares you can take. So, it will be 0.0001, this will be 0 and this will be 0.0001. So, this will be multiplied with these probabilities. So, k I minus k e square into p r I. So, this will be multiplied with these probabilities. So, you have 6 digits after decimal. So, this will be 25, this will be 0 and again this will be 0025. So, in fact, what you can do is you can find the standard deviation by summing all these. So, if you sum them that will be 0.000050. So, if you take that it will be something like 0.007, something like that, or 707 or so. So, this will be your standard deviation for such cases. Similarly, you can have, if you can even calculate for the earlier cases where you had the this value as k I and the respective probabilities were 45, 30 and 25. In that case we had when you had k 1, k 2 and k 3 values as so k I was 0.09, 0.10 and 0.11 and the probabilities were 45%. So, 0.45, 30% and 25%. That was the case in our earlier problem. So, it was 0.45 and 0.30 and 0.25. So, in that case your k e was 0.98, that is what we had calculated, and if you get the k I minus k e. So, it will be minus of 0.08 and this will be 0.02 and this will be again minus So 0.12. So that will be your so this is not 0.12, this is 0.12. So this is 0.09 minus 0. So minus of 0.08, and if you multiply this 0.11, so that is your 0.09, 0.10 and 0.11. So in that case it was 0.098, not that we have done some mistake, 0.098. So so this will be 90 minus that is 98. So it will be 0.008. So if you look at these values, so it will be 90 minus 98. So it will be 8008, and this will be 100 minus 0.002, and this will be 110 minus 98. So 0.012. So this is how your things will come up. You will take the squares of these values, and this will be something like 0.000064, and you will have this as 0.000004, and this will be 0.000144. So this way that is to be increased, and then this will be multiplied with the PRI. So with 0.45, 0.30, and then you can sum it, and you can get these values. So you can check, you can calculate these respective values, and you can find the expected rate of return. I mean you can find the standard deviation in such cases. So this will be for a particular asset X. Now suppose for asset Y, if you look at for the asset Y, and if you try to calculate the value of the standard deviation, and for asset Y again the data is given like you have K1, K2, K3 is given as 0.05, 0.10 and 0.15. This is your Ki, and its probability is given as 0.25, 0.50 and 0.25. In that case you can calculate the expected value. Expected value will be 0.10, because you see that this is a symmetry. So it will be 0.10. So you can get the value of Ki minus Ke, and Ki minus Ke will be minus of 0.05. This will be 0, and this is 0.05. So its square will be square into and then you have to multiply also with its probability, that is PRI. So it will be minus. So this will be 0.0025 multiplied by 0.25. This will be 0, and this will be 0.0025 multiplied by 0.25. So if you take its sum, in that case, so it will be 0.00125. So if you sum them, it will be summation will be 0.00 and 125. So you have to take its standard deviation and sigma y. If you look at, it will be you can have its square root, it will be 0.353. Now what you see, sigma x was coming as 0.00707, and sigma y is coming as 0.353. So it has meaning, if you try to find its deviation, if you find its standard deviation, if you find the probability density. Now if you try to show that how its variability looks like, so you can show it using the curves, like this will be showing the less variability, and this will be with the the larger dispersion value. So this will be for asset X, and this will be for asset Y. So that's how these standard deviation values are represented or they are seen. Now, if if we assume that this probability distribution is normal, if we assume that, then what we see that for the asset X, the 9.8%, which is the expected value, expected return for asset X. Now, it will be within plus minus of the one standard deviation, that is your 68.26% of the time. So, what is the significance of these curves? If they follow the this normal distribution curve, in that case it means that there is 68.26% of the time this is going to be within plus minus 1 times the standard deviation. So, standard deviation is your that the standard deviation for that. So, you have calculated the expected value, and expected value if you have calculated. So, you can see that it's you can take the plus sigma and the minus sigma, and for that you will have for 68.26% of the time it will be falling within that. So, similarly, if you go to 3 sigma left and 3 sigma right, then you are likely that it will be taking about 99 0.755% of the time it will be falling in that particular range. So, that is what the meaning of these curves are. Now, there is another important reliable measure of the risk, and that is known as the coefficient of variation. So, coefficient of variation. Now, what is I mean even as we rate the standard deviation even better, we call it for the coefficient of variation, and it is basically talking about the relative dispersion of data. So, this is the relative dispersion of data. So, this is basically around the value expected. So, we call it as the coefficient of variation, and it is denoted by coefficient of variation, and this is the ratio of standard deviation to the expected value. So, you can you have the asset X and asset Y data, and you can find the coefficient of variation for these two values, and if you find the coefficient of variation for X, it will be, we have calculated it is something like 0.007 and then 1 or so, and divided by 0.098, or that was calculated, that we have not calculated anyway. For the first case we had done this was 0.0707, and that is for expected value of 1. So, that was 0.1 in fact. So, this was 0.1. So, that way you had calculated. So, that will be 0.0707. Similarly, for y we calculated 0.0353, and its standard and its that was a standard deviation, and this was expected value was 0.1. So, it is 0.353. So, when you have higher value of coefficient of variation, in that case the investment seems to be more risky, and similarly if you have the lower value of the coefficient of variation, in that case your investment seems to be less risky or so. So, these are the standard terminologies which are basically useful when you talk about finding which of the investment is more risky or less risky, and so. Thank you very much.